In the last lesson, we looked at the basics for direct and inverse variation. Just to recap one or two key ideas, direct variation is in the form of y equals kx, where k is your constant of variation. If you were asked to solve for k, the relationship would be y divided by x. We saw that the graph is linear and it always goes through the origin. So 0, 0 will always be on your graph, and you will have what's known as a proportional relationship. So we're going to look at some more examples. This first one is, given these ordered pairs, find the constant of variation. So when you look at this, you really got to ask yourself, so is this either direct, which is y equals k times x, or is it inverse? And in direct variation, to find k, it is a ratio. You're looking for, if I divide y by x, do I get the same value? With inverse, you do product. If I multiply y times x, do I get the same value? So looking at my ordered pairs, if I multiply them together, here I get 96, here I get 24, 0, and 6. So it's definitely not inverse. So then I'm going to check, is it direct? I do y divided by x. So negative 8 over 12 would be 8/12, which reduces to, that would be what, 2/3, and then I do negative 4 over negative 6, 4/6, reduces to 2/3. 0 over 0, don't freak out, okay? 0 divided by 0 is undefined in mathematics, but if 0, 0 is there, that's a really good sign that this is direct variation because it's got to go through the origin. And then 2 divided by 3, yep, there it is. So y over x every single time produces 2/3, so that's our constant of variation. Okay, so I have answered the first one. Write the equation that represents us. Well, it's always y equals k times x, so y equals 2/3 times x is my equation. Now I'm told the variable y varies directly as x, and y equals negative 16 when x equals 2. So to find k, it is a ratio. It is y divided by x. Another way to remember that would be, think of slope. You're changing y every you're changing x. So I'm going to do negative 16 divided by 2 to get my k. It will be negative 8. So what is my equation? Well, y equals kx would be y equals negative 8 times x. So the final one here is find y when x equals these different values. So if x is negative 1, 1, or 2, it's just easiest here, I think, to set up a table. And you just plug in. If we're doing negative 8 times negative 1 to get my y would be positive 8. Again, negative 8 times 1, plug in, would be negative 8. And then negative 8 times my x value 2 is negative 16. So here are my y values. If the following ordered pairs represent direct variation, find the missing value. So if this is direct variation, my constant is equal to a ratio. It's y divided by x. So if I do 7 is to 2.8, that's got to be the same as negative 4 divided by x. These two things have to be equal, and that forms a proportion. And I mentioned before, we've got a proportional relationship, so it all comes together. How do we solve a proportion? We cross multiply. 7 times x is equal to negative 4 times 2.8, which would be negative 11.2. Then I divide both sides by 7, and I get x is 1.6 for my missing value. In this last example, it says which graphs represent direct variation. Again, direct is y equals k times x. So we said key features are it has to go through the origin. So I can rule out A and I can rule out C. Going through the origin would be B, and it's linear. I could find k by just counting the slope, which would be good practice, and D also goes through the origin. Just for practice to do this, the equation for letter B looks like my slope is down 4, right 1. So I'm going to say that that is y equals equals negative 4 times x. And this bottom one looks like it goes up 1, right 2. So it's going to be y equals 1/2 x for the equation. In our next video, we'll do a few more practice problems with inverse variation.